All right, so we're going to look at solving exponential equations. And so the basic setup of the equation is going to look something like this. You have a base to an exponent equals some kind of value expression, and our variable is going to be in the exponent location, hence why these are exponential equations. So I'm going to go through a few different ways of approaching these problems and how you can solve them. So the first type of thing you can do is you can try to match your bases on both sides of the equation. Now, sometimes the value on the other side will already be a power of your base on the left, and so you can just rewrite it in terms of that. But occasionally you'll run into situations like this where it's not. 27 isn't a power of 9, but there's a relationship between those two. Both 9 and 27 are powers of 3. And so what we can do is we can take both of these down to a base of 3 and then approach solving the problem. So let's get here. Okay, so I'm going to write 9 as 3 squared. That's the same as 9. I have my x minus 3. I'm going to write 27 as 3 to the third power. The rule of exponents, when you have a power to a power like this, you multiply those. So this is going to be 3 to the 2x minus 6 power equals 3 to the third. So now my bases on both sides of my equation match, and since I'm saying these two statements are equal, because the bases matches, that also must mean that my exponents must be equal to each other. And if that's true, then I can solve that problem. So I'll add 6, divide by 2, and I can write my answer as 9/2 or 4.5 if I want to start doing decimal values here, but that's how I can solve it. So if I can match those bases up. Now, I hope you see the problem in that a lot of times these numbers won't have anything to do with each other. Now, there are ways to still force a match in there, but there are better techniques to do it instead of that. So let's look at those other ways of doing it. So a second way of doing this is to change something from this exponential form, this base exponent equals value setup, into the logarithmic version of that. Log base on the base of the value equals the exponent. Now, before you can do that, you have to start by getting it in this first format. So here I have a problem, and what I need to do is get this 2 to the x minus 6 alone before I can switch formats. So I'm going to have to do some algebraic manipulation here before I get to doing this switching to the logarithmic form. So the first thing I'm going to do is I'm going to get rid of this fraction. I'm going to multiply both sides by the denominator. All right, canceling it out on this side. I'm going to go ahead and distribute this 4 through. So I'm going to get 4 plus 4 times 2 to the x minus 6 power equals 5. You'll notice I can't do 4 times 2 because I have to do the exponent first before I can multiply. I can't do the exponent, so I'm going to have to leave it like this for the moment. And what I'm going to do is I'm going to get this 2 to the x minus 6 by itself. So I'm going to get rid of this term, this 4 term. 1. And then I'm going to get rid of this multiplier of 4. So I'm going to divide both sides by 4. So that'll give me 2 to the x minus 6 equals 0.25, 1/4. And now I'm going to change formats. So I'm in my base exponent equals value format, and I'm going to go to my log format. So log, my base was 2 of my value of 0.25 equals what my exponent was, x minus 6. And now I'm just trying to get x by itself, so I'm going to add 6 to both sides of my equation. And I'm going to get log 2 of 0.25 plus 6 equals x. Now, the downside of that is if I wanted to go to my calculator and get a decimal approximation for that, this isn't something that I can easily put in my calculator. My calculator only does base 10 or base e, the common log or the natural log, but I can do a change of base formula to change this into ln of 0.25 over ln of 2 plus 6. So I can change it to that if I want to get a decimal approximation for that and use my calculator. So ln of 0.25 divide by ln of 2 plus 6, and oh, came out nice. So 4. And you should always check to see if it comes out nice. So probably if I had left this as a 1/4, it would have been a little bit more obvious to us that log base 2 of 1/4 is equal to -2. -2 plus 6 is 4. So that's exactly 4. So that's why it's always a good thing to check your work with your calculator to make sure it didn't work out nicely and you just kind of lost it with this decimal value, for example. So that's another way. A third technique is to take the natural log of both sides. So let's say I have this problem. Again, what I'm going to have to start off by doing is just like here, get the base exponent equals value by itself. So I need to get this 5 to the 4x plus 1 alone. So I'm going to move this 3 over, add 3, 2 to the 5 to the 4x plus 1 equals 14. Get rid of the 2, divide both sides by 2. So 5 to the 4x plus 1 equals 7. So let me rewrite that over here. And what I'm going to do is I'm going to take a log of both sides. It doesn't matter if you want to do the natural log or the common log. If you're dealing with base e, you should definitely use the natural log. If you're dealing with base 10, you should definitely use the common log. In this case, since we're dealing with 5, it doesn't matter. I'm just going to do the natural log just because it only has 2 letters in it and log has 3. But you could use either one. So we have a property of logarithms that says if you have an exponent inside of a log, you can move it out front as a multiplier. And now we have our x on our normal level, and I can try to solve that. So maybe I'll get rid of this natural log of 5. I'll divide both sides by natural log of 5. That'll give me 4x plus 1 equals natural log of 7 over the natural log of 5. And then solve this for x. So subtract 1. Divide by 4. And so I get an answer, natural log of 7 over natural log of 5 minus 1 over 4. Now, if you didn't like how that looked, you could kind of, straighten it up a little bit. I could make it look like natural log of 7 over 4 natural log of 5 minus 1/4. I usually don't make a big deal about that at this stage. I'm just like, okay, got this. And the nice thing here is this is ready to go in my calculator. Since I use the natural log, an operation on my calculator, I can now put this in. So put the whole top in a parenthesis, natural log of 7, divide by natural log of 5, minus 1, close the top, divide by 4, and so I get approximately 0.05, say 23. So that's a nice thing of doing the natural log or the log of both sides, is you get something that will naturally be ready to put in to your calculator. So let's do a couple other problems, a little bit kind of, I would consider a little bit more unusual type problems. So let's say I have this problem. What's kind of unusual about this is I have 2 different base exponent pairs. And the way I'm going to solve this is I'm just going to take the natural log of both sides. And then I can, again, take those exponents inside of my log and bring them out front as a multiplier. Since I have two x expressions here, what I'm going to do is I'm going to make this look a little ugly at first, and then to make it look nicer, I'm going to distribute this natural log of 3, and I'm going to distribute this natural log of 2. So x natural log of 3 minus 4 natural log of 3 equals 5x natural log of 2 plus 1 times, so natural log of 2. Then what I'm going to do is I'm going to get everything with an x, every term with an x on one side of the equation, and every term without an x on the other side of the equation. So I'm going to add this 4 natural log of 3 to this side of the equation, and I'm going to subtract this 5x natural log of 2 to that side of the equation. That's going to give me x natural log of 3 minus 5x natural log of 2 equals natural log of 2 plus 4 natural log of 3. These both have an x in common, so you can factor that x out. And now where you had 2 x expressions, you have 1 now. And then I can get x by itself by dividing by this parenthesis. So divide both sides by natural log of 3 minus 5 natural log of 2. So x equals natural log of 2 plus 4 natural log of 3 over natural log of 3 minus 5 natural log of 2. And again, I could put that in my calculator if I wanted to get a decimal value. You could also make this look a little nicer if you wanted to do something like, let's say, natural log of, what, 81 times 2, 162, natural log of 3 minus natural log of 32. And we're just using those properties that says if you have an exponent inside, you can bring it inside as a power. So 3 to the 4th power is 81. And then we have a property that says if you're adding logs, you can combine them and multiply the inside part. So 81 times 2, and that's where I got the 162. Same thing here, I could bring that 5 in, so 2 to the 5th power, that's the 32. I usually wouldn't put these together because the rule is if you're subtracting, you divide, and we don't usually like fractions within fractions. This is a lot more work that I would, again, really expect at this stage. Just getting it to the point where you have x alone and it's something you can plug in your calculator, that seems good enough to me. I would probably just stop here, but you can, you know, kind of put some stuff together if you wanted to make it look a little nicer. That's a way you could do that. All right, and then this last problem I wanted to go over was this type of expression. Again, it's got kind of something related to the last one in that you have a base exponent combination, another base exponent combination. But if you look at the shape of this, this looks like a quadratic. In fact, you could do the change of base to this and say, let's make u e to the x, and so u squared would be e to the x squared, so e to the 2x. And so you could change this into u squared minus 5u minus 24 equals 0. That change of base, if that helped you. And then you can factor it, u minus 8, u plus 3. If you can't factor it, you can always, you know, quadratic formula or something. So u equals 8, u equals negative 3. And then again, we're not solving for u, we're solving for x, so e to the x equals 8, e to the x equals negative 3, that's what u was. And because I'm working with e here, I'm just going to do the natural log of both sides of the equation. So natural log of both sides, that'll give me natural log of e to the x is just x. So x equals natural log of 8. Same thing on this one. Take the natural log of both sides. x equals natural log of -3, but we're not going to want to do negatives inside of our logs. So if you end up with something like that, just cross it off. This will be our answer. X equals natural log of 8 for these problems. All right, that's solving exponential equations.